Hello again. Welcome to another lesson in geometry. Today we are covering section 4.1, congruent figures. All right, so underline the correct word to complete the sentence. A polygon is a two-dimensional figure with either two or three or more segments that meet exactly at their endpoints. And this is going to have to be three. If we just have two segments, then we can form an angle with that. If we want to make it into a polygon, we need a third segment, and then we get a three-sided polygon called a triangle. If we want four segments, we can connect them to make a quadrilateral polygon, and so forth, pentagon, etc. Okay? All right, so there's something important here. The segments have to meet at their endpoints. So if I take this one and I go like this, that's three segments. They're not meeting at their endpoints, so it's not a polygon. And you can say, well, what if I add another one here? Still not a polygon, okay? Because this segment, this red one, and this green one are crossing over each other. So they're not meeting at the endpoint of all of the others, only at the endpoints of other segments, okay? All right, number two, cross out all the pictures that are not polygons. So this oval is definitely not a polygon, okay? There's no segments at all create an oval. This one is a polygon. Okay, that's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 segments that all meet at endpoints. Triangle is definitely a polygon. It has three segments that all meet at endpoints. This one's not a polygon, and this one's not a polygon. Okay. All right, vocabulary builder, we have congruent. Congruent, we've talked about already in terms of angles and segments. Remember, they were the same length. But if we talk about figures, congruent figures have the same size and shape. So for instance, these two squares would be congruent to each other. They all have right angles in the corners. And we'd say maybe all of the sides are 2. Okay, so two congruent shapes have exactly the same size and same shape. And we'll spend all of this chapter examining congruency for shapes, especially triangles. All right, so circle the triangles that appear to be congruent. I'm going to circle the first one and the last one. Those both look the same size and shape to me. The middle one's skinny and tall, and the third one over is too small to fit. Okay. All right, write true or false for each statement. So congruent angles have different measures. This is definitely false. Congruent angles should have the same measure. That was one of our postulates. A prism and its net are congruent figures. This would be false. Okay. A prism itself is like this, but its net is when it's unfolded. So we can't really compare a three-dimensional shape to a two-dimensional shape. Okay. The corresponding sides of a congruent figures have the same measure. So the corresponding sides should definitely have the same measure, just like up here, all the corresponding sides in these two squares are all 2. All right, on our second page, we have a key concept here, congruent figures. So congruent polygons have congruent corresponding parts. That means their matching sides and angles have the same measure and the same length. So when you name congruent polygons, you must list the corresponding vertices in the same order so that we don't get mixed up, okay? So for instance here, A is the top of the short side, and then it goes to the top of the long side, and then the bottom of the long side, and then the bottom of the short side. And when we name it over here as a congruent figure, we start the same way. So the top of the short side, top of the long side, bottom of the long side, bottom of the short side. And we need to name them that way so that people could draw the figures themselves and see how they go, who corresponds with who. All right, so number 7, use the figures at the right to complete each congruent statement. So AB is the top, and that should be congruent to the other top, so EF. Okay, all right, our second one, BC. So BC is from the top tall to the top bottom, and then over here, we're going to go from the top tall to the tall bottom again. So that would be FG. Okay. We're looking at CD now. CD is the bottom in each one of these. So CD. So that's going to be GH. Okay. So DA DA is the short side, so it goes from the bottom of the short side to the top. So we're going to have to name it from the bottom to the top here. So this will be HE. Okay. All right, angle A is the same as angle E. Angle B is the same as angle F. Angle C is the same as angle G. And then the last one, D and H are the same. So angle H. All right, our first problem on this, using congruent parts. Okay. So in this picture, triangle WYS and triangle MKV are congruent. Okay, that means their corresponding parts are congruent. So we're going to use this diagram over here to match up the corresponding parts. So draw an arrow from each vertex of the first triangle to its corresponding vertex of the second triangle. So W is going to match up with M. Okay. Y is going to match up with K. And S is going to match up with V. And that would mean something like this, that WY segment should match up with MK's segment. So we don't actually have to draw the triangles if we just know who goes with who from the congruent statement. Okay? All right, so we're going to use that congruent statement above to fill in all the sides. So for instance, WY is going to match up with MK, just like we had before. Okay? YS is the second two vertices, so we use second two vertices for the second triangle, and we get KV. And WS was the outside vertices in the first one, so W and S. So here we have to use M and V. All right. And then our angles for our triangle, W angle is going to match with angle M. Y is going to match with angle K. And S is going to match with angle V. So we just need to be careful we keep the vertices together. Okay, so the first vertex, the first angle, should match with the first angle in the second triangle. All right. Problem number 2, finding congruent parts. So suppose triangles WYS is congruent to MKV. Okay, so this seems familiar to me. And if the measure of angle W is 62, so let's go ahead and put in a 62 here. And the measure of angle Y is 35, so we can put a 35 right here. And then we want to explain the following. So use the congruent triangles at the right. Use the given information to label the triangles. Remember to write corresponding vertices in order. Okay, so let's see. So this is going to be WYS, so this has to be S here. And then the other triangle is supposed to go MKV, but we need to make sure they match. So the M should go in the W spot, because this triangle has been flipped around. And then the Y and the K should match, so the K is going to go in the top spot, and the S and the V should match, so the V would go in the bottom spot on the left here. Okay, and you could see like the YW is the longest side, so that's the first two vertices. So MK should be the longest side, which they are, because that's the second, in the second triangle, that's the first two vertices. Okay. All right, so complete each congruent statement now. What's the measure of angle W? Well, they told us that already, but what's it going to be congruent to? That's going to be congruent to M. So the measure of angle M. The measure of angle Y, which is 35, should be congruent to the measure of angle K. And the measure of angle S, which we don't know, should be congruent to the measure of angle V. All right? So use the triangle sum theorem to find out what angle S is supposed to be. So the measure of angle S should be equal to the measure of angle W plus the measure of angle Y, and then that should all equal 180. So S plus W plus Y should be 180. And that's from the triangle sum theorem. Remember, any three interior angles of a triangle should always add up to 180. So here we're going to subtract 62 and 35. And from 180, just get S by itself, and that should give us an answer of, I think, 83. Okay. All right, so let's complete these. So the measure of angle S is going to be 83, but S is also congruent to angle V. So the measure of angle XS is 83, and the measure of angle V is also 83, all right, because they correspond to each other. So we want to make sure that we put our corresponding angles and our corresponding segments together. Okay, on our third page, we have problem number 3, finding congruent triangles. So is triangle ABD congruent to triangle CBD? Okay, so is ADB, the one on the left, the same as CBD, the one on the right? Okay, so they look like they are, but in order for them to be the same, then all of the corresponding parts must be the same. So to prove two triangles are congruent, we need to show that all corresponding parts, not adjacent parts. Okay, two angles are adjacent. Two shapes can be adjacent if they share a side, but they're going to be corresponding is what we're looking for here to prove congruence. Okay, so circle the names for triangle ACD. So triangle ACD is isosceles. How do I know it's isosceles? That's the big one. It has these two marks on here to show it. Okay. And it is acute. If you do the right angle test with a piece of paper, you could try to slide it into angle ADC. It looks almost right, but it's actually a little bit smaller. Okay, so all three angles AD and C are less than 90. All right? Cross out the congruent statements that are not supported by the information in the figure. So AD and CD, oh, that's good. Okay. BD and BD are good, so we have two of the three sides from each triangle. Okay. AB and CB, there's nothing there to show it in our picture, so we can't do that. It looks the same, but there's no marks on there to tell us. Okay. There's no information about maybe BD being a bisector, right, of AC. So A and C being the same, we could circle this one, and that's because in our big triangle, we have two sides the same, and if two sides are the same, then the angles across from the sides will be the same. So this one and this one should be the same. Okay. And then ABD and CBD, they got no marks on those angles. Okay, they look like they're right angles, but we're not sure. And ADB and CDB, those are up here, and we have no marks on these either. So we can't, they look the same, but we can't be sure. So you need, well, let's see, well, we need all 6 of these things to prove two triangles are congruent. We have to prove all the angles are the same and all the corresponding sides have the same measure. Okay, so in this case, we cannot prove that those two triangles are congruent. All right, so we have a theorem here to help us a little bit. So our theorem is a third angles theorem. So if two angles of one triangle are congruent to two angles of another triangle, well, then the third angle is going to be the same. And that just makes sense. So if you have two triangles, this one and this one, in both cases, you could find the third one, which in the left one is angle C, by subtracting the measure of angle A and B from 180. And over here, we could do the same thing. So 180 minus the measure of angle D and the measure of angle E. Now, since we already know that A and D correspond and that B and E correspond, then we could get the same answer out of this. Okay, so it doesn't matter. So in this case, we can conclude that, hey, if two of them are the same, then C and F should also be the same. All right. So if the measure of angle A is 74, the measure of angle D would also have to be 74. And if B is 44, then E is 44. We get this information because we already were told that those two correspond, so they're congruent. So since both of them are pairs of those or that, then 62 is the only thing that will add up with these two to make 180. So 62 must also be the only thing that will add up with those two to make 180. And notice that C and F are the same, and that's our third angles theorem. It just says if two of them are the same, the third one has to be the same. All right. Okay, problem number 4 at the bottom of your third page here. Prove triangles are congruent. So given that this information, we have A and D the same, so that's already marked on our picture right here. And we have AE is the same as DC, so that's marked on our picture with those two little marks. And we have EB is the same as CB, that's marked with these two marks on each side. And then BA and BD are the same, so they have three little marks on each one of those segments to show that they're the same. We want to prove that triangle AEB is the same as triangle DCB. So what do we need? Well, we have three pairs of congruent sides, okay? We have one pair of congruent angles, just A and D. So we need a second pair. We can probably get it. And we also need a third pair, okay? So somehow or another, we have to prove this angle is the same as that one. And E over here is the same as C over there. So we have to get that into our proof, okay? All right, so if you flip it over, we actually have to do this proof, number 22 here. So let's go ahead and complete that. I just combined it into one page so that we could see the picture at the same time we're working on the proof. So complete the steps of the proof. So we already know that AE and DC are the same. That was in our given. And we know that EB and CB are the same. That was in our given. And we know that BA and BD are the same. So we have all the sides being congruent to each other. All corresponding sides congruent. Okay. All right, we are also given angle A is congruent to angle D. That was part of our given too. So those two corresponding angles are congruent. And then we have ABE. ABE was a green one in here. And we have that's going to be equal to, let's see, A starts with the one that's farthest away, so ours has to start with D. So angle DBC. It's going to be the same angle if we name it the other way, but we should always try to keep our corresponding parts in the same place. So this is true because they're vertical angles, so we can use that vertical angles are congruent, or you can write the vertical angles theorem in this spot. And then since we have two angles the same, we can get the third one. So angle E and angle C are going to be the same by the third angle theorem, what we just learned in the problem above. And then that means my two triangles are the same. So triangle AEB, that starts with the red angle, goes to the blue one, and then the green one, should be the same as triangle. Well, we have to start with the same angle, so we have to start with the red one, which was D, go to the blue one second, which is C, and finish with B. Okay, so triangle DCB. And that's by the definition of congruent triangles. How does that work? Okay, to get this, you have to have all 6 parts the same. So we have all 6. We have 1 here, 2, that's 2, that's 3, here's 4, 5, and 6. So we showed all of the segments were congruent, corresponding segments, and all the corresponding angles were congruent. So to prove congruent triangles, we must have all 6 parts the same. All right, let's do the lesson check. So as usual, you should pause the video now and give it a try yourself, and then come back and check your answers. Okay, so welcome back for our lesson check. Let's go through the answers. In each angle in one triangle is congruent. If each angle in one triangle is congruent to its corresponding angle in another triangle, are the two triangles congruent? So this really means, are they always congruent? So for instance, hey, if this angle matched this angle, and this angle matched this angle, they're both supposed to be right angles, and this one matched this one, would these two triangles be the same? Okay, so let's think about that. So underline the correct word to complete the sentence. To disprove a conjecture, you need, this is only one counterexample. Okay, just one. So our conjecture is they're always going to be congruent if all the angles are the same. So let's see if we can find a counterexample. So here's our warm-up question almost again. So looking now for equilateral triangles. We've seen a lot of these pictures already. So here is an equilateral triangle. Here's an equilateral triangle, and here's an equilateral triangle. And all 3 of these triangles, I marked them a certain way on purpose, all of the angles are 60. That's what makes it equilateral triangle. Okay? So since all of the angles are the same, Are all the shapes the same? Are all the shapes congruent? And your answer here should be no. Okay? So what's the answer to our question? Okay, well, all equilateral triangles have angles of 60 degrees. Okay? But the sides are not necessarily congruent. Okay, so remember, to be congruent, two figures have to have all of the angles congruent, which works for equilateral triangles. All these angles are congruent, but also must have all the sides congruent. And that's why I marked this one and this one with little 1 marks, because those are congruent, but that one in the middle I put 2 marks on because the sides are different lengths. Okay. All right, so check off the vocabulary you understand. So remember, to be congruent figures now, that's our new part of the word congruent, all of the angles and all of the corresponding sides have to be congruent. And then we've talked about polygons in the first one. Just be careful that you remember that the segments can't cross over each other. So this does not form a polygon. All right, so how well do you identify congruent polygons? Hopefully you're somewhere up here. If not, watch the video again. All right, I'll see you in class next time.